All right, welcome everyone. Very nice to see you all here. Thank you for joining in. Especially glad since today is the last day and this is the lunch hour and the 4th of July is just coming and everybody is really having some great plans around that. So it's very hard to get everybody in, so very happy to see all the faces from different teams and different organizations. Today's topic is on the evolution of big data pipelines at Intuit. So evolution is a very interesting, it's almost a campfire topic, right? Everybody wants to talk about it, but almost never got the time to talk about it. So this is that time. So let's get this done. You see engineers are working, they are not just building a system. We are orchestrating an evolution of things that will happen in the future. So it seems like a remarkable, powerful kind of mechanism, like engineers are actually having that kind of power to orchestrate an evolution. But it's also a very responsible job, because if you have to think about evolution and you're orchestrating it, it's very, very responsible, because there are so many things that you can do. It almost makes you feel like God, right? Because you have to manage the whole orchestration. So today's session is about that, and if it would be a very good session and you will enjoy it. If you are also in between the evolution, you are changing some of the data pipelines at your system, you are either starting to do it or you are at the beginning end, or wherever in position you are at, you will enjoy this if you can also recognize some commonality with your system and your organization. But in any case, just by being a big data enthusiastic, you will enjoy this session. At any point of time you want to tweet about it, these are the handles. Our handles are also at the Hadoop Summit site, Rekha Josham and RM Lokesh. So without much ado, let's get started. So let's introduce your speakers for the session today. Lokesh?
Yeah, sure. My name is Lokesh. I'm a software engineer at Intuit. Currently managing batch pipelines and working on re-engineering batch pipelines into stream-based systems. And yeah, I like photography.
Who doesn't, right? So I'm Rekha Joshi. I'm a principal engineer at Intuit. I have been working on distributed systems for quite some time now. Currently, I'm liking the Chopped series, where a couple of new chefs come in. They don't know really much about anything, but they're given some weird ingredients and a very short period of time, and you have to do something really beautiful. It's almost like an engineering analogy, isn't it? Because you always feel that when you're trying to take a system into production, that's how it feels like. So it is really beautiful for me. But let's discuss about the game plan for the session today. Today we are going to discuss about evolution as such. What does it mean? What was Charles Darwin trying to convey to you? Perhaps we'll spend about 30 minutes today on it. No, I'm kidding. We'll spend equally all the time in rest of the topics. So we'll cover the evolution itself. What does it mean? What does it entail? And at Intuit, what is the need for evolution? Why is Intuit and evolution even connected at all? And is it needed for anything in the big data environment? That is the need exactly, right? Unless you understand the need, you can't understand the topic. So that is the whole point of this evolution as a need. And how cool it would be if we could know the recipe, right? Because you have the design patterns, you have the reusable enterprise patterns, you know all about that. As engineers, we know all about patterns. Even if we see a thing, we know, recognize it as a pattern, right? We are built, our brains are now wired accordingly. But how cool it would be if we could recognize or have a recipe for evolution. How can I, when I go back to my office or my company, how can I orchestrate this evolution this way? So the recipe would be really cool, wouldn't it? So let's see if that is possible. Are there some ground rules that can be laid out for evolution itself? But most importantly, evolution doesn't happen like you dream about it and tomorrow it is all done. It happens in stages. Recognizing it and then taking it forward is essential. So this is a critical point that we'll touch upon. At Intuit, how did the evolution happen? How did we go through different stages? Were there some stages that we recognized, and what were they? So we'll talk about that as well. Finally, we'll open the floor for question and answers. Again, we'll love to hear from all of you. It might not happen, all of the questions may not get solved today, but we'll love to hear all of the questions and all of the feedback. So data@Intuit.com is an email address where you can always reach out in case there's something that left undiscussed today. So this is a game plan, so let's go ahead. So like I said that we want to really touch upon the Charles Darwin theory of the on the origin of species, right? Many people have read that book, right? People who have not read, please raise your hand. Or people who have read, please raise your hand.
We read it, but we know about it. We learned about it.
Okay, so it is a 700 pages book, or 700. So we'll cover all about it in 2 slides. The main gist of it is evolution is change. It is happening everywhere, it is everywhere. But the whole point is that from unicellular organisms like amoeba who were not capable of doing much, let alone thinking, we have evolved all the way from there to human beings who can do a lot of stuff. So that is a huge amount of evolution, and it is not very visible to the naked human eye, right? You are not seeing it as it is happening. But after a few years, you will recognize that some set of evolution has happened in your capabilities also. So it is human beings can do a lot of things, right? Their endurance, their capability. Olympus is a very good testimony of what all human beings can do. But that is all evolved from a unicellular organism. To even imagine such a thing has really happened blows your mind away, doesn't it? But it is happening, and the change is constantly happening even today. But another aspect of it is, if you can't evolve, you disappear. And I like to put the dinosaur pictures because it really makes the audience happy, but it also brings a sparkle back into my eyes. It is something that really existed on the planet Earth. It was walking, living being, spewing fire. You cannot imagine that such a thing was there, but it is not existing at all right now. What happened? It didn't have a need to evolve. It just disappeared. But the whole matter point of it is that things that cannot evolve disappear. So there are only 2 just to evolution then. Evolution is change, is happening continuously, and is everywhere. But things that cannot get evolved disappear. In my mind, lizards are actually the evolved form of dinosaurs, but that is a story for another day. But here, when we have talked about evolution as such, right, in 2 slides I have given you the whole idea of the 700 pages book of Charles Darwin, but evolution is happening. But how it is happening in big data itself? So big data is something that has evolved not just to mean as data, but as a set of whole technology that can do a lot of things. We can capture, store, analyze, visualize the whole data pipelines in a manner that is scalable, that is reliable, that is which is efficient and as well as a bit economical. So Apache Hadoop is, woohoo, 10 years! Who else is excited? it's 10 years this time for Apache Hadoop. And I was at Yahoo and working at Apache Hadoop since its beginner, so I'm pretty excited. So it has actually evolved into multiple different fashion, because once it started, it was just MapReduce and HDFS, and then got into different resource management. It has now the whole ecosystem around it with different tools and technology, from workflow management to different kind of orchestration, even the visualization, Zeppelin and different stuff. So big data itself has evolved incredibly from its history. It's almost like the teenager who is very, very accomplished right now. So coming back to Intuit then, we know on evolution what it is and how the evolution happens, right? And big data has also evolved, but how is Intuit and evolution, how is it connected at all? If you read our mission, it has very tightly coupled with evolution, because it calls out to improve our customers' financial lives so profoundly, they can't imagine going back to the old way. And the new way always becomes the old way, right? So every day you are evolving, and you have embraced the evolution theme very intimately. So who we serve, all of you might be using some or other of Intuit product, because it's a critical financial services, that it's a data that is finance data. And I always call this out, that economy is a key driver of any civilization. So finance data is really the topmost data that you can have. And we have different applications. At Intuit, we have about 65 different applications. Number keeps on growing, but at least we are flowing almost 25% of US GDP is flowing through these products. These are the numbers, and you know the turbo test, QuickBoost and the Mint. So numbers is very huge. That's a large customer base with the financial data, which is very, very critical. But let's take a step back and think about why is Intuit an evolution case study? Because I said it is a change that is happening. It's happening continuously. If people don't change, they disappear. But hey, Intuit has not disappeared. It has almost 30 years of computing life in it. It has been working since the era of DOS. And multiple technology changes that happened, whether it was client-server technology or messaging framework or the mobile applications or different flavors that were happening in the environment, Intuit has actually embraced it and continued to evolve. With a large customer base, it is a billion-dollar finance industry with very, very critical financial services. But do you see there's one point here that is very, very important. It's the data that is at the heart of it. It's the data that is flowing around different applications. So in fact, you can say that if your body is a vehicle to take your brain from one point to another, all the applications are nothing but a vehicle to take the data from one point to another. It is the data which is playing the role of everything in all the applications. So there are different regulatory data, transactional data, and different flavors that have come across. And this is not the end. This is not the end goal at all, right? It will evolve. We know it. And at this point of time, we know that data is a decision maker. Because if right now anybody comes to you and talks to you without any having substantial data, it's just an opinion. But we said that, hey, there is the whole flavor of evolution. There's Intuit is a evolution use case, but what is the need for evolution at Intuit, right? So at the point when we started, as we said, we were in DOS, we were in client server, we were in messaging, we were in mobile, we were in different things. You know, the data was flowing, but as the data keeps on flowing and the organization keeps on growing, the data really takes humongous proportions. And the way it is being handled by different teams also becomes a bit ambiguous and needs to be handled really clearly. So we found that there was a singular need for a singular cohesive data pipeline, a data pipeline where you can have all the different aspects of a data pipeline being handled in one place. Also, the cloud environment became a very important thing to have a scalable, economical way of scaling the system. Whether you have to scale up or you have to scale down, whether you have to have an automated deployment, then cloud environment really became very, very important. We have done multiple prototypes on cloud environment, which is the right one, and everybody has their pros and cons. Where is a Google cloud environment or AWS or Azure, they have different cloud environments that are available to you right now. But Intuit, as we have gone with AWS as all-in, and we have found it to be working really well with different financial services right now onboarded in production on AWS. Also the secure part of it, right? It's almost like you go to the airport, you find that when a security guard is checking your bag, it's an overhead for your journey. You don't want you to waste your time there, but it's really for you. So security is always like this, right? It is for you, whatever the overheads are there. So we have to take care that whatever systems and methods or auditing or governance or compliance, we adhere to it so that it is always beneficial to the customer in the end. And I do not know how many people attended it, but we had a very mind-blowing meetup that happened a couple of days back. It was a A/B testing meetup that we started with the Netflix and a couple of other organizations to have an A/B testing meetup. It started with just 10 people, but right now is a 1,000-strong team. People attend from different regions and organizations to understand more about A/B testing. And it's nothing but data-driven decision making. So it is one of the key use case that Intuit platform, data platform solves for. But it cannot happen if there's not a single data pipeline to it, right? If everybody is doing it in a different manner, you cannot have a decision making done correctly. Similarly, the personalization is the end result of being the data-driven decision making. You can personalize the different customer, how does a customer interface with the product, because all the customers need not see about 100 screens, right? If they are shown that, it is really bad for the product. So we try to minimize the effort the customer has to take to achieve the end goal. And the streaming has become a really important for the real-time use cases, and we have Apache Kafka, Apache Spark, and multiple other things in the POC, whether it is Flink or K-stream, B-stream. So there are multiple things that are in POC, but we have it all leveraged upon by data pipeline. And there are multiple other such use cases. So like I mentioned, that evolution of data pipeline, you cannot dream about it, sleep on it, and tomorrow it's done. It happens in stages. And as I called out in the audience, some of you might be even going through those stages right now. But every time when it happens at Intuit, the whole mantra is, and this is a very important key mantra, we try to follow thin slices and minimal viable product. So that if you see the first stage, it's also a workable solution. Even the 5th stage is a workable solution. It's only the bells and whistles that get added. But it's very important that the first stage itself is a workable solution, even though it doesn't have too much fancy stuff on it. So anytime we are onboarding or trying out some new things, we try to take the thin slice and get it working end to end and get it productionized so that it is a workable solution, then go ahead with it. So I called the evolution of big data pipeline, hey, it would be so good if I had a recipe for it, right? And big data pipeline is nothing but, if you have to say it simply, it is ingestion, it's digestion, and sometimes it can lead to indigestion. So there are 3 steps to it, right? But that's calling it out very, very simply, because there are so many different units that you might have to support. If you imagine that single cohesive data pipeline was a good thing for you to have, because you can have the same commonality, you also have challenges, because then the data that is going to come to you is going to be really, really huge. It might come to you from different kind of people, it might come from you different formats, it has different frequency, it might have different needs altogether. How would you ingest in a manner that is scalable, that is effective for the big data pipeline? Because the pipeline is really eating a lot of stuff. So how would you do that? Essentially, the key theorem that we maintain here is the endpoint for the customer, that is the API, where it consumes or ingests the data, remains irrespective of what the data format is. It is agnostic to it. So the API remains the same. So then it's easier to ingest. You can have new onboarding, you can have new units coming in, new type of data. You can extend. It is open for extension, but it is the same API. Transforming the data, right? You have to have the system that can transform different data, and it might be reusable component. So what we also call our data pipeline is a platform of loosely coupled, platform of a chain of loosely coupled reusable transform components. Because as you work on data pipeline, you will see that there are some functionality that is reusable across different units, and you can make them as a block of or chain of components that can work together as a DAG. You can orchestrate it in that way. So it is pretty much digestion, but the digestion sometimes is common, sometimes it's very unique, but you can make it as a chain of a loosely coupled reusable components. But with all this data, all this volume, would you think that indigestion will never happen? That is not our understanding. Actually, the indigestion does happen. The system is very huge, system is handling a lot of stuff, but then how would you handle when it is not able to keep up with the scale or having some issues? So a system is only an evolved system when it can respond, it is responsive to the failure itself, or it is responding to an error in a situation in a way that is not affecting the customer at all. So that is what we target for, and that I believe are the ground rules when you are trying to do any evolution for any kind of data pipeline. But evolution of data pipeline also has this concept, right? There is also underlying parents that whenever we are trying to solve for a customer, we try not to have a snowflake solution. Like different customers will come to us with different needs and different requirements, but having a snowflake solution is like, I'll have a solution per customer, and that really doesn't scale well. Especially if you are a large billion-dollar company, you want the data pipeline on which it is depending upon is very efficient and not having the snowflake kind of effect. But then it's really hard, though engineering people don't tell you, but engineering is development plus the messy part that nobody talks about. And this is really important messy part as well, because when you are trying to change or morph a current system to a new system, there are people who are not only effort-wise invested, but emotionally invested in the current system. They have spent their Fridays or Saturdays or whatever, right? They spend those days in their current system. So if you are evolving, getting them agreed to the new system or the new advantages of the new system, right, that helps. Also the standards is very important thing, right? When you're building a big data pipeline of such nature, we have to take care of the security, the audit, the governance, the metadata, the PII, the fields. How are they going to come together? It's very easy to do it if it's a single cohesive data pipeline. So this is the recipe, and in a funny note, we are breaking the silos and moving the organization in one direction. But there are some other aspects as well. If you have read that PhD paper where we are now exposed to lot many configuration knobs that are necessary or that are being used even. Like Hadoop has about 500 odd configuration knobs. Every distributed environment has so many configuration knobs that you have to spend some time to understand how they work with each other or how they are helping to fine tune the system. So there is some work that goes there. And at some, like I mentioned that at Intuit we have like a bacteria culture, you are investing in prototyping different solutions, but you have to test it out, and sometimes it works very well on your laptop, on your single data stream that you are flowing. But at Intuit we are passing about 30,000 events per second, almost about 600 megabytes event per second, and that is really the scale, right? So you have to test the latency and the throughput at that scale is working correctly for whatever is your solution. Some of the things I mentioned earlier, but most important thing is the SS itself, right? If you have a very reasonably, very well having a feature rich or a capable data pipeline, it still is useless unless people have access to it. People can work on it. And controlled access is a very important thing because who has access and why and how much level of access you have, that is really important. But it finally drives the innovation because unless people have access, they can't do anything, they can't think of future way of doing it. And at Intuit, we believe that evolution is not the dead end, it's still happening. People have to think about more things and come up with the new ideas as well, and it will grow. So it is parallel now. What is a data evolution and organization evolution is one and the same thing. They both go hand in hand and they both serve each other. Some of the slice view that I have given here is even if you have data coming from different devices, whether it is mobile, online, laptop, it flows to the same REST endpoint. It gets ingested from the same REST endpoint. And you have a chain of loosely coupled transformable components which are doing the transformation. The endpoint might be something as needed, and it could be profile store for the profile use case, it could be personalization engine for personalization use case, but there is this is a slice view. In the current system, we are on AWS S3, EC2, EMR, Direct Connect, VPN, and different deployment tools from CloudFormation to Terraform. There are alternatives. One is lightweight to the other, and there are different monitoring tools that we use. Also, there's monitoring where we get the PagerDuty alert. But like I mentioned, the evolution did not happen once I got up in the morning, it was all done. It happened in stages. Let me call upon Lokesh to discuss about all the stages that we went through. Thank you.
Thanks, Rekha. So as Rekha mentioned, like it didn't happen in one day. So we got to do it over time, and like what happened during that time, like how the pipeline evolved. So I'm going to walk you guys through with a set of examples, like where we started, like what made us to change to another stage, and like reasons behind or requirements behind like changing those pipelines. So to start with, like Intuit has various products, and like all those products have like variety of applications running to power those products. The problem with this is like all these products and applications are in silo, meaning like all have their own way of like handling data. They have their own data store, and like they have their own way of processing and like producing like analysis results. This is problem for us, right? Like because we have a product which uses variety of applications, you cannot even exchange data that easy between these applications. What this means is like you cannot like evolve the product like in a quick manner like you really want to evolve. So this provides a challenge, and like it's also an opportunity for us, right? So we can bring like products close to each other, and also it will solve a problem for us, like from the time where like if you want to analyze something, like it's taking like n days or x days from like to bring it like as close to real time. So that's the journey we started. Knowing these issues or challenges, we started with a set of requirements. So this is just a subset of the requirements we got when we tried to build out our first stage of pipeline. So at really high level, like the goal is like, if you look on the previous slide, like data is in like different locations. So we want to bring data into one single location. So it's easy for anyone and everyone to access and like provide valuable insights out of the data. The second part is like we need to make it a common solution across Intuit. So like we need to handle requests at scale. So the requirement we started with is like 200,000 requests per second, and all these requests are like having variable payload size, which is between like 3 and 5 kilobytes in size. So we would read those messages, do some enrichments, and like provide it in the format in which consumers want it to consume off of. So this is like at a high level for us to get started. The first stage, like we have event streams, like which is being like handled by a bunch of different applications, and we need to put it in a location where like it's easy for any of us to access and like produce valuable insights. Like Hadoop is like a one of like the unique choice we made. Reason being, like it comes with set of features, like it's highly available, it's redundant, so you don't lose data. So we chose like Hadoop, and like we use Hive for our data store, because there are some downstream applications which read from Hive, do some transformations, and either they load it into, for example, Vertica, or like furthermore processing, and then like goes to another system. So one problem we solved here, if you look at it, is like data is like coming from various sources, but they all end up in Hadoop, like in one location. So this solved the problem of like having data in like various locations. But as I said, like evaluation is continuous. So like you need to constantly think about like what other things you can do to make your system better. So can you think of like a reason or why we want to evolve from this stage, right? Because we achieved the goal of storing data in one location, right? The challenge is actually like people can, or like various applications can easily send in data to the system, but like to consume, either they need to have access to Hadoop or Hive to consume it, right? There is no like higher level abstraction around this data. So that's logically led us to another stage where like we need to use a higher level of abstraction for users to consume and produce data to our common infrastructure. So we went ahead and exposed all our endpoints, like REST. We built REST endpoints to consume data and publish data to all our applications. And Kafka became our natural choice again here, because like we need to handle like requests at scale, and we need to respond as quickly as possible. So we need to store these things like in a persistent way, in a durable way. Like, so we need to move to Kafka, and then we have other processes. Like we use Camu, for example, like to move it from Kafka to Hadoop. Anything after Kafka doesn't change, because like the goal is still same. Like we need to have data on one point. So at this point, we solved the problem of like people trying to access and produce data without any challenges actually. So with this achieved, like we saw like lot of adoption like across Intuit. Various products like started using our application or pipeline. Once you see like good amount of adoption, like the immediate thing is like everyone's going to ask for like, is it highly available? So this system at this point is not highly available if you think of it, right? There is no redundancy. There is we need to bake that into our pipeline, so that like our upstream applications and on our downstream applications doesn't suffer because we are going down, or like we are seeing some failures. So this led us to have a system that supports HA and DR, right? This is really critical. Like today we take it for granted, but like if you just like go like few years back, not many of us were thinking about like HA and DR. So now like this is many of the applications we build today like is starting with HA and DR, like, but we evolved from like very like one set of like environment to like variable. We can expose our services in like variable data centers, so that we can achieve HA at this point. But the challenge here is like if you look at this, we chose AWS as Rekha mentioned earlier, based on like various benchmarks our teams have done. But like once we have HA like based on AWS and then our data center, the challenge is to move data from AWS to our data center, right? So we use Kafka mirroring for that. But this produced an interesting set of challenges and opportunities for us. As a developer, we develop pipelines, like we test it, like we scale test it, everything works fine, and like we productionalize it. But one interesting thing happened here is, our production environment, when we went live and we were handling data at volume, and what happened is we need to bring data back to our data center. So we realized we are being throttled actually by our network team, and we could not understand why, and we had to sit with the network team, and this led us to understand the underlying architecture through which the data is flowing through from end to end. So understanding that it's actually flowing through a bunch of firewalls, and it's hitting proxies at some endpoints, so which is actually limiting our data transfer rate. And also this bandwidth or this pipe is being shared with various applications. So we have to basically understand all the infrastructure, all the way data is flowing through, because HA and DR is easily achieved, but you need to understand the architecture or the network architecture of your systems as well. So this is really happened for us in last year's production time, we saw we are not able to move data as quickly as possible, which is going to affect all our downstream applications, because the ingestion part is okay, right? Because we can scale easily on AWS, and we can handle all ingestion. But if we cannot move data in defined time, then we cannot meet our SLAs. If we cannot meet our SLAs, it's going to have impact on downstream applications. At the end, some customer might get impacted as well. So we were working tirelessly day and night to resolve this issue. So to solve this issue, basically we need to understand, as I mentioned, the underlying architecture of the network of our data center, and also we need to understand what's the pipe, how many applications are running, how much data each of these pipes are each of these applications are consuming, and how much we can take for our application. And once we figure those things, we went ahead and upgraded some network appliances. We increased our pipe. We tried with Direct Connect, and then when it comes to Kafka, we have to do a bunch of changes on the broker side, on either side, from AWS as well as on our data center, and then on the mirror maker, you have to do a host of changes to achieve the throughput we wanna see. And once we do this, we can, move data without any problem. This really helped us to meet our SLAs and, have no impact on, downstream applications. And one other thing, which is not mentioned here, I really want to call out. When we go HA and DR, the other thing we really want to test out is, you need to really test for different direction in which data can flow, right? If there is a failover, let's say for some reason AWS is not available, then all your traffic is going to flow through your data center in this case. So you need to make sure that works fine, because there are a lot of things like SSL certificates. Can you handle the traffic all at once? You need to test for those things. You need to deliberately bring down various applications or these pipelines are deployed in in one of the data centers, so that you can see if your system is resilient to those failovers. So the next logical step is once we achieved HA and DR, if you remember in the previous slide, we don't have any compute part in the AWS. So we slowly want to move all our compute from our own data center into AWS. So we took that in a very phased approach. So and while we are doing that, we had a choice, we can set up Hadoop in AWS and do the computing, but we went ahead and benchmarked few frameworks, and then we went ahead with Spark for various reasons. So we started with streaming use cases, right? So Kafka, you have various, for example, if you want to support fraud, if you want to do real-time customer support, we use Spark streaming for this case, to transform those events and write back to Kafka, and downstream applications can consume off of it. But we still mirror data back to our data center and move it to our Hadoop, because that's one source of truth for all the data. So the next stage is we want to be be on like cloud only. Like what it means is like we want to do all our ingestion and all our compute in the cloud, and we want to bring data back to our data center as only for like DR reasons. And then like if you want to do any batch analytics on top of it, we can actually do. So I just want to take a couple of more seconds to explain this. Like as I mentioned, we want to do compute on AWS. So what it means is when we have a streaming application, we can read off of Kafka, do all transformations and write back to Kafka, and downstream applications can consume it. But there is also like a set of different applications running to move data from Kafka to S3. So S3 is also like becoming like one source of truth. Like eventually, like we want to move to AWS only solution, so we might not even be mirroring data back to our data center. So once data is in S3, then you can run your Spark batch jobs, and then like you can empower your analysts to use Spark SQL, and then like produce results what they want to see it. But this is future state. We are not there yet, but we want to be there like as soon as possible. So talking about the pipelines, we have a working pipeline now which can move data end to end and like all the stuff. But some of the things which are really essential, which we didn't talk about it so far, is monitoring, metrics collection, and alerting, right? So it's not like you cannot have a single system, a single application that can cater all those needs. At least from our experience, there is no like one solution fit all kind of thing here. So for most of our AWS pipelines, like we use CloudWatch to collect metrics. For our applications, we use New Relic, and we use Splunk for log management. And then for EMR and other clusters, we use Ganglia for collecting metrics. And PagerDuty is commonly used between our data center and AWS to alert like engineers, operations, managers for that matter. So and like on our data center, again, like we are mirroring data. We need to monitor the bandwidth, like how much we are hitting, and like are we exceeding our limits and all those stuff. So we use Sensu for again like host monitoring. We use Graphite for collection. Like we build dashboards using Grafana. So it's actually like if you look at it, this is like a host of features you're using just to monitor and like alert your system. So this slide, I really want to talk about this because if you think about it, Intuit is actually like some of the products we use are really seasonal. So for example, tax product, right? Like you're going to see like a huge traffic like between January and April, and then like it's going to like go down actually. Even within January and April, there are like certain time period, like you're going to see like huge spikes, and then like it's going to come down. This is actually like a sample snapshot of like weeks of data. If you see like it starts all the way somewhere from 100 million, it spikes all the way up to 700 million, right? Like events. So the reason I bring this up is like this provides us a challenge as well as an opportunity, right? Like if we can design a system which can easily scale, and also like which can easily like you can scale in and scale out, it will be like cost effective for us, and it will also be like easy to maintain. Like you don't have to maintain all the time like a huge cluster or a huge number of machines. And the other thing is really like trust by verification. Like this is not about the testing we do before we go to production. This is like when you are in production, when the pipeline is up and running. Like one thing like we really do is like we want to test all our observable endpoints. What I mean by observable endpoint is like to any place where like data is at rest, or like data you can get access to. For example, you can read data off of Kafka, you can read data off of S3, you can read data off of Kafka in our data center in HDFS. So you need to look into like all of these locations and see like if data are being like like available within like defined SLA time. And data loss is something like we take like really seriously, because we cannot afford to lose data, because once you lose data, like you are not able to reliably predict like what the user is doing and all those stuff. So data parity is another thing. Like we know like how this data needs to be transformed, like, and we test this against our expected output. Like all these things happen in production. We have like a way to differentiate our test data. So yeah, so with this, like as I say, like evolution is continuous. Like we are continuing to evolve, and we would like to like keep doing this, and like this is really an enjoyable journey.
Yeah.
Yeah, so we have a lot of openings, so reach out to this link or like write to us data@intuit.com. Thank you, guys.
Thank you. There are about 10 milliseconds for questions. If there's anything, I would like to hear from you. Yeah, yeah, please. Yeah, we had heard about Apache Falcon in some of the InMobi colleagues, but right now we are not using it. We had done a prototype on that, but we found that mirroring is working better because of the Kafka ecosystem.
Sure.
Are there any? Yeah, go ahead.
You make changes to the mirror maker, right?
Yeah.
Have you contributed it back to the?
No, actually, it's
Yeah.
more about the settings you do to your host machines and configurations. But I've written a blog about it, so you can check it out.
Also, what we found is we were using the Kafka 0.8, 0.2, and in the later versions at Kafka 0.9, 0.01, most of the issues were resolved. So it's also in technology, the new releases itself solve those problems that we are facing, but it's a feedback that we give back to the Kafka community. Any other? Yeah, go ahead.
How do you do the validation in production?
Come again?
You mentioned you do validation in production. How do you do that very well?
So we have ways to identify what is the test data. So we only publish some set of test data, like Lokesh mentioned, right? This is just the testing of the production flow, but we have done rigorous performance testing almost with the 10 times greater load to the expected load. Performance testing has already happened. The pre-prod testing has already happened. The functional testing has already happened. But in production systems also, we continuously check. And it's like a heartbeat, right? You keep on checking whether the data loss is not happening with your test topic, whatever you want to. But there's an in-house tool that we have built to enable that to happen. It's a whole suite of products around testing. That is an excellent question because it's really needed because how would you make sure that the production is also working fine, right? And then you have to make sure that it is a test data that you're sending so that you have ways and means to delete the data if you need to because production data should not have extra data, right? That's a very good question. Anybody else from this side? Any other questions? Oh, yeah, go ahead, please. Yeah. Didn't see you.
What is? Oh, band. So initially we had around like I think 4G or something, but we use Data Connect and we have like 6 or 8G actually exactly. I don't know the exact numbers, but it's more than 6 gigabytes.
Yeah, we had some network improvements as well. So we are using the different network configuration. I'm not exactly sure what is the network configuration, but we changed the network configuration as well, both on in-premise private data center as well as the direct connect, because we had to test a lot, and like Lokesh mentioned, we worked overnight and stuff to get that issue resolved. Can I hear another question? Somebody? Is there another question here? I think we are done, right? Okay. Thank you so much. Thank you so much for joining in. Have a nice 4th of July.